Hello and welcome to C++ Weekly. I'm your host, Jason Turner. In this episode, I'm going to talk about the apparently 6 different ways that you can end a program. This is another topic that was suggested by Ben Dean. And there are things that I didn't know existed until I dug more into this and read his comments. So I'm sure you'll learn something new too. So I suggest that you stick around. This week's episode is sponsored by HRT. If you've attended any C++ conferences this year, there's a good chance you've already heard of HRT, as they have sponsored several conferences. HRT is known for its deep engineering culture and strong focus on performance, and they are looking to hire the sharpest engineers to help them to develop and optimize the technology at the core of their business. They're headquartered in New York, but they have offices in Austin, Chicago, Boulder, London, Dublin, and across Asia. They're looking primarily for C++ and Python developers. I know, since you're a viewer of C++ Weekly, you are a C++ programmer, and you probably already program in Python too. So go ahead and check out the link on the screen for openings that they have. And remember, you don't need a financial background, just strong engineering fundamentals, and they'll teach you the rest of what you need to know. Now, I kind of wanted to do this like a D&D character alignment chart, but I realize I'm not very good at that kind of thing, so maybe I'll just try to mention it from time to time. And I can't decide if I want to start from the best and go to the worst. Maybe I should. That'll keep you watching longer if I start with the best. Anyhow, expect my analogy to fall down at some point. Let's start with lawful good. This is not the right header file. There we go. This is the technically correct way to exit from main. Nobody really does this. There's the lawful neutral, perhaps. I'm saying 0, although it's technically possible that my operating system doesn't use 0 as a success return code. This is perfectly valid C++ if the function is actually named main. So I don't know, this is maybe chaotic good or something. I don't know. Like I said, my analogy is going to fall down really, really fast. So I'm probably going to give up on that. These are all like fine. This one is a little bit out there. I say success, but I return a code that's likely interpreted as failure. Okay, those are all the things that you've probably done before. That is basically option 1. I just realized I'm going to end up with 7 options in here, not the 6 that I originally had planned for. This is perfectly valid. I've got my helper function. Let's see, helper function. It jumps if not equal to line 12 here, fine, whatever, and then it calls exit, and it exits with the value 0. Exactly what I expected it to do. This is fine. Let's go ahead and make a quick little helper just to prove what we're talking about from here. All right, we got this wrong. So I'm calling helper function, I'm executing the program, and I'm not getting my destructor printed out. So if I'm going to put false here, and now I guess the problem is on exit, there's no return, so there's no stack unwinding to happen. So this is incorrect. Let's go ahead and make this a static. And make sure all of our on-exit handlers are called, which they really, really should be. Okay, they are. Automatic objects are not cleaned up. The stack is not unwound. Okay, number 3, abort. This, well, can happen a few different ways. Interestingly, this abort is going to actually raise the abort signal. And we can also indirectly call abort with an assert statement. Release builds work, debug builds fail if I have this assert in here. So this is somewhere on the like chaotic, I don't know, neutral something? Yeah, I'm bad at this. I'm definitely bad at this. What you need to know about abort is that no cleanup happens at all. So if I'm going to change this function to one that calls abort app, then even my static objects do not have their destructors called, and I get this sig v. All right, that actually worked. I didn't actually expect Compiler Explorer to allow me to register a signal handler. So that's interesting. Now notice this lifetime of this thing is still not cleaned up. We're going to have to talk more about quick exit in a minute. If I call exit right here, this program has undefined behavior. I'm curious, okay, so the standard explicitly says I'm not allowed to call exit in a signal handler. But if I did call exit here, then I've converted this abort into just a regular old exit, basically. That's weird. All right, that was number 3. Let's see about number 4. That's right, I actually intended number 3 to be quick exit, not abort. That's all right. So quick exit. This one is interesting. This thing only calls the @quicks exit handlers. Let's try to play with this. Now we're going to register 2 different exit handlers here. These need to be just plain function pointers, too few arguments. So it's a function that takes no parameters and returns no parameters, okay? And I can do that with a lambda. I'm calling delete L here, and notice that I have registered my @exit handler, but I'm calling quick exit. So I'm going to call exit instead of quick exit, and I can see that that object is destroyed. Let's go back to quick exit, and then we will make this an @quick exit handler, which confusingly has all of the underscores when @exit had none of the underscores. It called my destructor. I'm sure of it. But the quick exit doesn't flush buffers. So let's do the delete and then call a flush on standard out. Now we're getting that destroyed message printed. Very good. Number 5, terminate. Terminate is interesting. Just like that, I can just call terminate. It ends the application. This is part of the exception handling stuff in C++, technically. So let's go ahead and include the exception header. This is implicitly called with unhandled exceptions. So I can directly terminate, like we did here. And then there's the very indirectly terminate. This is one of my favorite ones. Now the compiler is complaining at me here. I have -w error equals terminate. So apparently warnings as errors is catching this here, because this throw is guaranteed to always call terminate. For the sake of the rest of this example, I will be turning off w error. This is surprising, shall we say, to the readers of your code. If you have a function declared no except that throws an exception directly, it's just simply going to call terminate. Well, there's the other option, I guess. I am now going to always have an unhandled exception that is going to be thrown from indirectly terminate maybe into my really indirectly terminate always function. That's always going to terminate as well. Number 6, cause undefined behavior and hope to crash. This one is fun. Let's just go ahead and explicitly invoke some undefined behavior. Like this. This is, well, let's see. Program terminated with sigseg v. Okay, I've got O3, I've got GCC, I'm in my UB crash maybe. Where is it? UB crash maybe. This calls my favorite CPU instruction called UD2, which is an explicitly invalid opcode exception. This is great. So it just crashes, no matter what. But that's in GCC in O3. Let's go ahead and put this in Clang. And we will see that Clang probably isn't going to crash here. It sees the undefined behavior and simply removes the code. And look, everything happens exactly like I expect. There's some local object that was destroyed. Where in the world is that one from? What in the world? This is great. Let's see. UB crash. Let's look at where's main. Main. Okay, so main has no body to it. That was removed because of the undefined behavior. And the way the compiler arranged this code, the function do quick exit happened to be underneath it, which is the quick exit function we have up here, which explicitly calls quick exit. So what we thought was UB isn't in Clang. I mean, it is, but it's not going to crash like we wanted it to. All right, fine. Let's try to do something like, so floating point exception, probably not going to get us a crash. It did not. Oh, but it already saw the UB on the line above it. Let's go ahead and give it a different undefined behavior before that undefined behavior. Okay. Use of undeclared identifier. Oh, oops. All right. Floating point division by 0. Probably not going to crash. Expression result. Okay. Let's do integral division by 0 and see if we can get something. No. Let's go ahead and turn off the optimizer and see if we can get integer divide by 0 crash. It should do that. There we go. All right. So we're getting the crash where? Where are we getting the crash? Not there. Yeah. Oh, there we go. I get a sig floating point exception in GCC at O0 in this particular code. And I get no crash at all in O3 because it removed the entire operation. Undefined behavior is very unpredictable. Now, the next thing, number 7. We could do something like this, hope that the watchdog catches us, or on Linux, I know we can do something like this, which would be something like, let's create a vector of int. And I want to create a vector of a lot of ints, far more memory than I have. Maybe we could do something like that and hope that the operating system kills us. This was a little fun and silly, but let's get a little bit serious, and hopefully you've stuck around for this, because this episode has gone way longer than I expected it to. Hopefully I can edit it down to something reasonable. This is my actual suggestion after researching all this. I would do something along these lines. You'd have to be very careful to make sure you do this correctly. But I would register the @quick_exit handler, and in the @quick_exit handler, I would save my state as much as possible, probably to a new file, and flush the output. I would also register a abort handler, and in the abort handler, I would call quick exit. If I either want to exit the program very quickly or some unknown thing happens, then I am going to save the state as quickly as possible and just let the program die. You might even let the terminate handler call quick exit. This seems like a fairly clean way of handling these situations where you either want to shut down very quickly, like a large application, or, and possibly, you want to handle unknown state. You're going to have to probably set a global flag that says unknown state versus known state so that your quick exit handler knows to save over the known good file, or if it needs to write a new temporary file that it could recover from. I don't know. Leave your comments. Hopefully this was an interesting episode. Thank you for watching. I'll catch you later.